Hi guys, welcome back to our lesson. So now we are in the last segment of our show, and this is where we are now going to explain why we cannot divide by zero, right? And I'm going to try and play around with some numbers in order for you to see exactly why we cannot divide by zero. But first, let's just remind ourselves as to what are the types of numbers where we are dividing, right? And those numbers are the rational numbers. So remember, rational numbers, we said these are any numbers that can be written in the form of a over b, where a and b are integers, but provided that b is definitely not equals to 0. And then the operations that we have is your plus, your minus, times, and your divide, right? So what we said, if I now divide by 0, you need to look at what number you choose, right? We chose any number. Remember, I chose 9, and when I divided by 0, I got what we call an error, right, on our calculator. This means that it does not give us any number that is not a rational number, right? So it is not giving us a number that is not it's giving us something that does not exist. I would understand if it was giving us a number that is not a rational number, but another type of number that we can classify. But it is giving us error. Therefore, it is not giving us any number for that matter. So, meaning there is no number to represent a division by 0. As a result, we normally write the word undefined to mean anything divided by 0. But also, let's say now we try and talk about this in terms of algebra, right? If I have a times b is equals to ab, then we know that if I have ab divided by a, where this is my multiplicative inverse, right? Multiplicative inverse, then I will get the answer to be b, right? But what if I have a times 0? And a times 0, we know that is equals to 0 for all values of a. It doesn't matter what a can be. But we don't have a unique answer when we then divide by 0, meaning the multiplicative inverse of 0 here. There is no way that you will get that, right? Because how many times does 0 go into 0? And by the way, the other thing that now that I'm just doing this, I'm thinking to myself, remember when you started doing division in your life, right? In maths, that is, at school level. And they taught you to say divide is the same as when you are grouping a number into groups of that number and you are counting how many are there. So for example, if I say 10 divided by 2, I'm saying group 10 in groups of 2 and then count how many are going to be there. Now, if I say divide 9 by 0, how do you group 9 into groups of 0? You see, so that does really not make sense. So that's one of the ways you can look at this, guys. I'm just really trying to throw out the things that I'm thinking, which I'm hoping you are also trying to think now as to why will this not be true? Why can we not have this as a fact? Because it gives us an error, and an error in mathematics is not part of a classification. No, it's just an undefined solution. So another way of looking at this, which I want us now, this is what we are going to do together. Firstly, we're going to divide a positive rational number by a very small negative rational number, right? So let's say I have a positive rational number can be 0.5, right? And I divide this by a very small negative rational number, so negative 0.1, let's say that, right? That's where I'm going to start. And then I'm going to take the 0.5 as well, and I divide it by negative 0.00001, right? A very small one, right? And I want to see what my answer is going to be for that. And then I'm also going to take a positive rational number. Now I am making my 0,1 and 0,00001 to be positive. And then I want to see what exactly happens. So I'm just going to go here so I can write these numbers down. So firstly, I'm going to have my 0 there, right? And I'm saying we are taking the number 0,5 as our integer 0,5, right? We divide it by negative 0,1. We also divide it by a negative 0,00001. It doesn't really matter how many zeros are there. I'm just trying to make it a very small number. And this is 0,5 divided by 0,1, 0,5 divided by 0,00001. Now, let's see what will we have, right? So I'm going to have 0,5 divided by negative 0,1, and this will give me negative 5, right? And then we continue and then say, what if I say 0,5 divide by negative 0,00001, and this will give me that. So now I'm at negative 50,000. So this one gave me negative 5, and this one gave me negative 50,000. So in simple terms, even on this side, this will give me a positive 5, and this will give me 50,000. So do you see? The smaller the number that I am dividing by, meaning the more it is approaching 0, the bigger the negative number it becomes, right? It is big and negative. Like, it's not a big number in terms of the number line. No, it's a huge number, but on the negative side. So it is approaching negative infinity. So this is approaching the negative infinity. So the biggest number you can ever find that is negative. And then even with this one, it is approaching a positive infinity. So you can see here that there is what we call the discontinuity, right? The discontinuity that we are seeing here, meaning there is no way that there will be any number that will approach 0 or will approach a specific number if we are dividing by a smaller and a smaller number each time. So that's one of the ways we can really look at this whole concept of dividing by 0. Now, remember we said, excuse me, the set of numbers that we have, right? What are real numbers, right? Real numbers will be numbers we can use to count, will be numbers we can use to mark positions, that is 0. It will be whole numbers, it will be your rational numbers, your integers. But now, what if we want to be more specific about this? We normally use the symbol R for real, and at times it's normally like that, right? Where there's like 2 lines there, which is how I try to show you there. So this is a union of rational numbers and irrational numbers, right? So this is a union of rational and irrational, and the operations are all the operations that we've used so far: plus, minus, times, divide, the root, and the cube root. Now, the set of numbers that we have are all these numbers that we have in the universe are real numbers, right? Remember the roots. We looked at roots of numbers that were positive, right? But now, what if I say numbers that are negative? Will I still get the same answer or not? That's what I want you to think about, right? Which is what we are talking about here. So to say, if we are to find a square root of a negative integer, what will that do for us? Will it give us a solution, or will it give us something that does not exist? But because mathematics, everything exists, it gives us what we call imaginary numbers, right? Where we know that the square root of -1 is equals to iy, because according to imaginary numbers, I squared is given to be equals to -1, right? So meaning, if I have a square root of -1, this will be the same as square root of I squared, which is the same as I, right? Another example will be maybe if I have a square root of negative 4, this will be the same as the square root of negative 1 multiplied by 4. I didn't change anything, I just wrote it as 2 factors. And this will be equals to the square root of I squared times 4. And then you know square root of I squared will be I, and the square root of 4 will be 2, so it will just be 2I. Hence, we call them imaginary numbers. The I stands for the imaginary. And the operations that we use here are plus, minus, times, divide, square root, and the cube root. So more like all the operations. And then we also have what we call the complex numbers. The complex numbers will be what you call the combination or the union of real numbers and non-real numbers, right? So this is more like non-real numbers. We call them complex numbers. And these non-real numbers, remember we said these are the same as imaginary numbers. These are imaginary. And then the operations, we still use all the operations. Now, the last thing I want us to try and look at is to classify these numbers. Now, firstly, is this number a counting number? Definitely not, because I can't have 5,5 people. Does that mean the sixth person is a half? Really, that would not make sense. And then also, is it a whole number? No. Is it an integer? No. Is it a rational number? Definitely. So firstly, for it to be a rational number, it starts by being a real number, which is R, and then it becomes a rational number, which is Q. You remember that? And that's all that we will have. We will not have it as an irrational number because it can be written as a fraction. And then with this one here, if I solve it, it will be negative into negative 3, which is equals to positive 3. So as a result, this is a real number. This is a natural number because we can count with it. This is a whole number. This is a rational number. It is also an integer just before it becomes a rational number. It is an integer, which is a z, and then it cannot be an irrational number. And then the last number that we have is 0, which cannot be classified as a positive or negative number, but this will be a whole number, so it's n0. By the way, this whole of mine here must be n0 like that, right? To mean whole number, the proper way of writing whole numbers. It can be a whole number, it can be an integer, and it definitely cannot, it can be also what is that called? A rational number. Here I almost said irrational. It can also be called a rational number or classified as a rational number, and this is a real number, and that's how you then classify numbers. All right, so the summary of what we've looked at thus far is that numbers are not all the same. We know this for a fact, guys, that numbers are not the same. We have actually showed you why they are not the same. And then if you group numbers based on some operations, I promise you it will give you a specific set based on those operations. And then the last thing is division by 0 is not a number, it is actually undefined. And that's what we needed to look at in terms of numbers, guys. I really, really hope that all of this clarified what the concept of a number is and how do we classify these numbers to try and make sense and use them in different contexts in mathematics. Guys, that's all from me. I have to love and leave you. I hope you've learned so much as I enjoyed imparting everything that I've told you today. But from me, remember, mathematics is food for the soul. Until next time.